Hello viewers and good morning from Asla and welcome to today's webinar from Pfeiffer. Before we go into our topic, I first want to introduce you to this environment here with GoToWebinar. So in the end of the webinar, we will conduct a Q&A session, so you can, over the complete webinar, submit us questions in the Q panel, and we will go through the questions at the end. If you want to receive the slides, after the webinar, there will be a post-webinar survey, which we would like you to fill out. And if you want to receive the set of slides, just answer yes. And you can freely adjust the screen arrangement around us here. So you can adjust the settings, like if you want to see the presentation or if you want to see us in the camera view as you like. So feel free to arrange the screen as you want. Today, we are talking about the topic outdated to optimized. And we want to discuss how you can upgrade your coater or your vacuum furnace in a way that you can benefit from possibilities with new technology. And don't worry if you do not operate a coater or a vacuum furnace, but you are interested in vacuum technology. It might still be very, very interesting for you what we are talking about. And today, I'm not alone.
Yes. Thank you for the introduction, Martin. I'm Simon van der Steen, based in Belgium. And yesterday evening, I realized the second half of my life, I was always involved with the vacuum industry, so it starts counting. I'm working as a market manager, thin film deposition, in a global team at Pfeiffer, which is part of the Bosch Group. Yeah.
And my name is Martin Fischer. I'm also working as a market manager responsible for the thin film industry markets as well as general industry areas. And yeah, together today we want to talk about different topics around renewing vacuum equipment on a vacuum system. So we want to focus, as we already said, on coatings systems and on furnaces. But we will not talk about the entire machine. So we will definitely focus on the vacuum part of things. And what we want to explore is we want to see how also the process that you are conducting in your system can have an impact on the choice of the equipment that you are using. And we want to discuss with you what to consider when you are choosing vacuum equipment or when you are making the choice of renewing parts of your system. And yeah, of course, there has been quite a journey over time
Yes.
in the development of the vacuum equipment on such systems.
Yeah. So this with this slide, we just want to show that there are some differences over time. Yeah, we go back 20 years, but can be 5 years, 10 years, or even older. What we see, what we notice in the market on coatings and furnaces specifically is a lot of things stay the same. The chamber, the sizing, quite similar. Yeah. On the other hand, time is money. Cycle times needs to be shorter. So this is a request we get quite often. But in this webinar, we will work on the small updates we suggest for your machine. One thing that we notice in the market as well, the pressure range is always similar. Yeah, if you go 20 years ago, it's the same. That means that vacuum is still needed. We also see in market trends, new technologies, that the pressure level is always under vacuum. You can see the vacuum as a good thing, as a bad thing. We see it as a good thing. You might see it as a necessary evil, but it's definitely part of the machines. So if you have a 20-year-old machine, we suggest making it ready for the next 20 years because you will need it in the future. A small metaphor we want to use during this webinar. We might come back a few times during the presentation. Very simple, a house. Everybody has one. Yeah. So a house that is built nowadays has definitely different standards than 20 years ago. Isolation, you have solar panels, you have new heating systems. What we want to refer as an example in this webinar, a simple example, if you have a 20-year-old house, you still have normal lights. Everybody replaces them with LED lights. Well, similar things on your coating or furnace systems. Now, how are we going to present this? We selected 4 reasons. We can say it in that way. 4 reasons to change your machine. 4 chapters, and then a few typical cases. First of all, serviceability. We will talk about that. Makes sense. If your material is out of service, you have definitely a risk for the production safety. Quality in general, we will explain it. Energy savings, I think it's obvious. We need to talk about that.
For sure.
Make it smarter, and some typical cases.
Yeah, before we go into the first topic, we want to reach out to you, dear viewers, and get your opinion. And our first question that we have for you in our poll is, how old are the pumps, or how old is the vacuum equipment on your systems, on the equipment that you're operating, if you have a coater or a vacuum furnace? So you will have the possibility now to fill out a poll and answer this question. And that would be very interesting for us to get to know your environment a bit more, so we know that what we are talking about.
Yes.
And I think that's very interesting because we talked about it. You had a challenge in Belgium when you reached out to your customers asking what is the oldest pump which is still operating in the field.
Yeah, we made a small competition. That's true. It was a customer event where we invited the audience to show the oldest still working turbo pump. Yeah, and it was amazing. We expected old pumps, but it was an event mainly for R&D, so universities could be specialists in keeping things alive. But yeah, it was more than 35 years old.
35 years.
The turbo pump, the
double flooded geometry.
Yeah, still working.
That's amazing. So sometimes equipment can get very old, but of course, you will have to service it, and you will need the possibility to serve it as well. Yeah. So this is something which is very important. And I think we can close the poll by now.
Yeah, we will share the results with you. It's a little bit as expected, in fact, and it's good news because we see, as you should see yourself, many of the pumps are 10 to 20 years old.
Wow, already.
That's good news.
So already up to 2 decades in operation for the equipment. Yeah, of course, that's very nice for us to hear because we see that the equipment is working for a long time. But also this shows us that it's a very, very important topic to keep this equipment alive. That leads us to the topic of serviceability. So what do we mean with that? With serviceability, we mean that you want and that you need to have the possibility of serving your equipment. Before we go into that topic, why do we need to service equipment? There are several reasons. So of course you have wear and tear to your equipment if you are using it. So over time, for example, the lubricant in an oil-sealed rotary vane pump will degrade over time, and if it's a mineral oil, it will change its color from very bright to close to black at some point.
Yeah. Maybe interesting to say also reactions, contaminations. You know, in vacuum world, our material is pulling things towards it. Yeah. So things can happen. We know that, and quite often we get the customer or the feedback from the vacuum users, if I can call it like that, related to reactions. They say the chamber is clean. It's not dirty. There is nothing. It has to be your pump that has a problem. Now you have to always think about your reactions because many things can. You have physical differences between your atmospheric conditions and your vacuum chamber. So this is an example of how you have to think in the total picture for failures.
Yeah, you can have contamination of course also, which is going into the pump, which is affecting parts of the pump, which can degrade seals, which also can result in condensation happening in bearing regions, which is affecting the lifetime of a product. And also, of course, electronics.
Electronics, definitely.
Semiconductor parts age over time.
No one can say how long they will last when it will get broken, but we see this in the field. Yeah, on a lot of installations where turbopumps are installed. Turbopumps is a typical example. Yeah, it's clean conditions because furnaces, coaters can be seen as more clean applications. The turbopump, when it's a magnetic levitated, there is no friction. It keeps spinning, but the lifetime is depending on the electronics.
Yeah. So serviceability definitely is a topic. There's many reasons to do that. And this is also shown here on this graphic, what we actually do when we service equipment. So we elongate the lifespan of the vacuum equipment. If you don't do service, the runtime, the uptime, and the reliability of your equipment, which is of course very good in the beginning when you purchase the product, will degrade over time, over usage, over wearing the pump, or wearing, tearing the system, and will eventually end in a failure in the end of life. So we do maintenance in between, so we have a downtime for a short period, but this improves again the reliability of the product. And so step by step, we can elongate the lifetime of the pump, which eventually also will end at some point, but we will definitely have an extension of the lifespan. So what we do is, I would say, a bit of survival for our vacuum equipment.
You can compare it with your car. You can do maintenance to keep it longer alive, but at some point it's end of life.
That's right. Yeah, and of course also we can make a difference between planned downtime. So when you take away your vacuum equipment from the system to send it in for have a bearing exchange or just to maintain it within your workshop. This is something which is usually plannable, which is a bit shorter, which gives a very good extension of the reliability. On the other hand, there might be also the case that you, after some time, experience a failure of the product, which gives you unexpected downtime, which can be a bit longer because you didn't really have the possibility to plan, and but which also should result in elongating the lifespan.
Yes, and that's definitely a cost everybody should calculate for his own situation. I mean, if there is a production stop, people are waiting next to the machine, or it's a critical part in the production line. That's very depending on each situation, of course.
And now we saw that many of you are operating already equipment which has been in operation for 1 or 2 decades. So the question is it still feasible to do the maintenance on this equipment, or is there a point where you could actually talk about replacing it to something new, because it gets hard to get replaced? If we look at this graph in the beginning, when you have quite new equipment, you can keep up a very good performance level with small maintenance efforts. Yeah. Then it goes into time, and then the wear to the pump components is increasing. The performance level is decreasing, and so the efforts that you need to put into keeping the system still up and running and performant will increase. Yeah. And at some point, you will have a lot of efforts to keep the pump alive, and you still don't reach the performance level that you had in the beginning. Yeah. And in some cases, it can be fun. Talking like you had the example with the car, yeah. With old timers. So, for example, this can be much fun, but sometimes it's hard to get the parts. And to replicate, for example, something can get very expensive, but you still won't have the performance that it had right in the beginning.
Yes, indeed. At the end of the webinar, we will also go more into the direction of this predictive maintenance, as we call it, which is different than preventive maintenance.
Exactly.
Okay.
Yeah. And simply talking about availability of spare parts or of replacement parts, that's also a topic. Of course, when a new product is introduced into the market, there will be a very good availability of spare parts. There will be a stock level which is kept alive in the manufacturer's warehouse.
As a pump supplier, we have to.
We have to. And also we have to, after we discontinued the product, we will still have replacement parts available. And sometimes there's also the possibility to source replacement parts from a third party.
Yes.
But at one point, when the equipment is getting older and there is a less demand in the market for spare parts, of course, the price to keep it alive will increase.
I don't want to worry too many people, but for those who answered that between 10 to 20 years old equipment, yeah, it might be that spare parts or service is limited.
Definitely. So serviceability is a topic which you can, or which you should keep in mind when thinking about renewing vacuum equipment or not. So it's very important to sum this up, that you understand what kind of equipment you're operating. So what is the age? What is the service status of your equipment? Is service still available or still possible for the equipment? And if so, then you can of course plan spare part availability, spare part requirements for the upcoming time when you intend to operate the equipment. And if you do so, of course, you can save some money, because if you have unplanned downtime, costs of course much more than maintaining the good performance of your equipment. Of course, that saves a lot of nerves because nobody wants unplanned downtime. It's very stressful.
Compare it to the house again with the heating system. If you know that your system is not repairable anymore, the technician said it every time. You know the consequences. You can be in a cold house, no hot water. You have to replace it. But if you replace it, on the other hand, proactively, you can even save money on energy saving.
That's right. So it's
small
definitely
comparison.
right. Yeah, and it's definitely feasible to review all the different options. So that can include refurbishing products. That can include exchanging used pumps by exchange pumps or replacement pumps. Or it can also include, of course, going into new products, even different pumps. But that's something that we also come to later. Okay.
The next topic, quality. Quality, see it in general, right? It's a name that can be a lot of things. What we want to highlight, or I try to imagine myself in your position, as a machine builder or an end user. What you want, I pick out the orange boxes here. You want high quality end product, and you want to have the production safe. That are, I think, if I were you, your two main reasons. You want a good quality product, and the machine should be running.
Availability. Yes.
There are other things that, of course, obviously link to that, and we will highlight them or explain them a little bit more in details over the next slides. Not too much because we can keep talking about several topics. Leak testing is one. We just picked one slide, but of course, if you have more interest, there are several webinars on our website that you can find only related to leak testing.
Yeah, there's plenty of options that you have. So on our Pfeiffer webpage, you have the possibility of accessing several parts of content. That can be white papers, but there's also several webinars which we already conducted, which you can call up and watch. And that is very interesting about leak detection applications, methods. Very interesting.
Strongly suggested. It's on Pfeiffer Vacuum knowledge webinars.
Yes.
Why I picked out this leak detection slide, nevertheless, it's because it's some important suggestions. So all the furnaces, all the coaters, all the vacuum installations, or definitely high vacuum installations, have been leak tested. I mean, that's what I assume. That makes sense. Now, if you do this leak test, we strongly suggest to connect the leak detector behind the turbo pump or even at the hose pump. If you have a 2,000 cubic meters an hour hose pump and a 15 cubic meters an hour leak tester, you want the main flow going. So this is just a small advice I wanted to add with this slide. And very important, a leak can also be a water leak or a liquid leak. In other words, we had this situation quite often. You can spend hours on leak testing. You know there is a leak, but you cannot find anything with tracer gas. Remember, definitely on older systems, could be a water leak. 1 liter of water in liquid state, in vacuum, it's a huge volume, less than 1,700 liters.
1,673 liters at atmospheric pressure. So, of course, when you want to go to vacuum, then this 1,673 liters expand, and with decreasing pressure, you have an increasing problem, of course. So you definitely don't want to have a water leakage in your system, and especially thinking about the quality of your products that you're making.
Yes, indeed. So we see, leak detection doesn't work. We see two other methods: pressurize method, not going into details; residual gas analysis. That can be more interesting. So I pick out just a preview of this technology. The residual gas analyzer, RGA, mass spectrometer, whatever you call it, it just takes a look inside your vacuum. It can see all different masses, not only helium, but it sees everything. Two main advantages, or two purposes where we see this in the field, and we see it more and more. One, at the initial state, before you start the process, it gives you a very clear indication of the water content mainly, but the general status of your machine. So if you bring things in the machine, you want to measure if you have new samples, for example, that are put in the machine, you want to see what is still outgassing, what can have an influence.
You will see that very soon when you're operating an RGA system.
Second reason, during process, you can do a better monitoring, process follow-up. Instead of just mass flow controller injecting gas, you can go to real life measurements. Very quick one, this contamination, because linked to quality, you don't want to have any influence either from the outside or from some things that are brought in with your carrier, with your samples. Or it can be on the inside. Definitely with inline machines, we see more and more that there is a gas separation chambers and that there is any avoidance of this cross-contamination, as we called it.
Time for another poll.
Time for another poll.
So, dear viewers, we want to know, is it important for you to replace wet pumps with dry pumps?
Yeah.
So you will have the possibility now to fill out the poll and to give us some answers. And yeah, that's definitely also a very interesting question. And as you said, you spent half your life in vacuum technology. For me, it's already a bit more than half my life. And I know when I had the first contact with vacuum technology, it was about 20 years ago. When starting studies and then going into the first experiments, you instantly, I'm a physicist by training, you work with vacuum always. So everybody was in that time telling, yeah, there is dry pumps, dry for pumps, scroll pumps coming up by now, and in
oil pumps will disappear.
Very soon there will be no rotary vane pumps with oil anymore, and everything will be dry. And here we are standing now in 2025, and we still sell you rotary vane pumps. So
maybe meanwhile, while the answers are getting in, one short explanation about what is a dry pump, what is a wet pump. A dry pump, per definition, is a pump. Everything that goes from the inlet to the outlet have never been in contact with oil. But it does not mean that there is no oil inside of your dry pump. In fact, many dry pumps have oil inside, and this is also an advice. Check the oil level of your dry pump because it is sometimes forgotten.
You still need to lubricate gears, for example. So I think we can close the poll. We have quite some answers here, and it's interesting. So we see everything. There is some people saying that they've never reviewed actually switching to dry pumps, and we're better off using with wet pumps. And on the other side, there's also some of you who say, yes, definitely, it's a topic for us, and we want to investigate how we can switch from wet to dry. And I mean, that's completely okay, and that's what we see in our daily work as well, because it's not a matter of the pumping principle, it's a matter of the process. If the process is requiring you a wet pump, go for a wet pump. If a process is requiring a dry pump, it can be completely fine to go on a dry technology.
These answers are in line with what I expected, indeed, Martin. Just one slide. Is a wet pump or a dry pump better? I think we can do a full webinar about this.
Maybe there is one.
There is no answer to this, or the answer is it's depending on the setup. It's depending on your preferences. What we can do is give a quick overview of the two technologies and the differences. First of all, a wet pump, oil lubricated, it has oil, but the oil has advantages. See it like that? It cools the pumps way better. It can seal on the inside, and this is important. We can have bigger tolerances, bigger openings between these between rotor stators, and the oil will seal it, leading to a better end pressure. That's in general. I mean, there are several pumping principles for dry as well as for rotary vane pumps, but at the end, the sealing gives a big influence on your end pressure. Price, technical comparison, oil pump would be better in many cases. On the other hand, dry pumps, they have longer maintenance intervals. Why? Because let's take a screw pump as an example. The two rotors are rotating, but there is no friction. Only wear is on the bearing parts. So by consequence, longer maintenance intervals. These are just
some case on the sealing parts as well. You might have some wear, but of course it's much less than you would have in pumps where you need to constantly exchange the oil, which is an active part of the pumping principle.
So from the Pfeiffer Bush side, we will not push you into any direction, but we try always to explain the differences between both. Okay. Another aspect which is linked to quality, and I just wanted to highlight this quickly without spending too much time on this. We as a pump manufacturer need to do a crash test. Simple, like a car manufacturer, he makes a brand new car, and what is he doing? He hits it to the wall just to see what the consequence is. We do the same with our turbo pumps. We have here an example. in this on the table here. There's a turbo pump. Turbo, it means it goes at very, very high speed. Yeah, the high speed can only be reached because of the vacuum pumps. Now, what we do, we inject a metal part in this to give it a full crash. Very important for us is that this pump will stay connected. The housing stays connected to your vacuum chamber. This is what you need for safety reasons. You don't want to be the person in the room with the pump exploding next to you.
When
These
the
are
pump is
razor
detached.
blades that are, yeah.
Exactly.
So, okay, so far so good. The pump is well attached. Now, many situations there is a valve in between, and this is also something that has been changing since gate valve, pendulum valve, it's changing over the last years. There are now certificates that the valves are also resistant to this crash moment. That's in fact what I wanted to highlight.
And especially the combination between the pump that is applied and the valve that you are using. It's very, very important that there is a match, and there is the possibility that we certify this to you as well to make sure that it's definitely safe in operation.
Yeah. There are also angle valves that did not exist 20 years ago with small stepper motors, can have safety influence as well. But keeping an eye on the timer here, we proceed to the next chapters. So what we can say as quality, I said in the beginning, what you want, best end product, and production safety. Well, the conclusion for me is you really have to look at the machine, take a closer look, understand your machine, see where you are, because it's all quality related.
It's always a matter of the process in the end.
Yeah.
You need to think about the process and the requirements of the process. Our next topic is very, very important topic. We talk about energy savings and the possibility that we have to save energy using the right vacuum equipment. And before we go into this topic, also we want to go into the next poll. So we are asking you, is energy saving for you, for your company, is it an actual topic? Do you want or do you need to investigate on energy savings, for example, in the next 5 years? So that's going to be very interesting also for us to get to know your feeling about this. Is energy saving for the vacuum technology a topic? And I mean, at home, thinking back to your example with the house, I think it's a big topic. So
I think it's depending on the region, of course, where you live, as well with the houses as with your vacuum installation. But indeed, we see a general trend, and this is needed, I think, to have this closer look.
For sure. And I mean, at home, it also means to invest in your equipment. Partly, it also means to maybe change the way how you use the equipment. So only heat if you're not venting, if you not have the windows open.
Make it smarter. It's all linked together.
I think we can now stop the poll and take a look in your answers. And I think it's very interesting. So we see that some of you have already invested in more efficient refurbishments of your vacuum system. But the vast majority of you is actually planning to optimize into the energy efficiency, but is not yet in the state that they have actually conducted it. So many of you are thinking about that right now. And of course, in some cases, it's also not a topic. I mean, sometimes if we look into furnace, into heat treatments, of course, the energy consumption of the vacuum pumps is the vast minority compared to the energy consumption of the heating systems. There it's maybe not so much of a topic, but it always depends a bit on the environment. But in general, it seems to be very interesting for you. And that's also something which we observe in our daily work, and also which is in correlation to the energy prices which we see worldwide. Of course, after the heavy peak in the energy price after the Russian attack on Ukraine, we saw a backdraft into somehow an equilibrium state of an energy price where we are right now. But if we compare it to pre-pandemic times in 2019 and look at the energy price equilibrium by then, we see that we have an increase nowadays about plus 50%. And looking at the development, it doesn't look like it's going to decrease very soon. So saving energy is also a topic when we look on our vacuum pumps and our choice on what equipment to use on our tools. And the question is, where can I save energy with the vacuum system? There's three main topics. So of course you can renew equipment, and you can choose pumps with electric drives, which just have a higher efficiency compared to former times. That is something that you see also in this graph, which we have shown here. So we have, as an example, we have two different roots pumps. We have a roots pump with a conventional drive, an asynchronous motor, and this is the blue curve here. And we also have a red curve, which is more modern, a novel roots pump with an integrated permanent magnet drive. That's something that you see here on the right side, where you have a drive directly integrated in the pump and directly acting on the pump shaft. And we see a strong difference, especially in the range of high pressures, that the power intake of the new generation is way less. And of course, with a comparable performance than you would have with a conventional pump. And also in the range of the base pressure. So mostly when you conduct the process, the pump will run in lower pressure regions. And there's also a difference which is quite strong for the new technology drives.
Yeah, we have a special webinar about the calculation and saving costs or saving energy on vacuum installations. This is something we do not want to do in again here. We do no double work, but we can really suggest to go to that one. So the total cost of your vacuum system is one of the webinars available,
yes,
where you see on installations, could be coaters and furnaces or other, where we do some calculations about other pump types and different methods to replace pumps by newer.
And also thinking about operating modes. So with modern equipment, you often have the possibility to switch into a standby mode as soon as the gas load is not as heavy, or as soon as you don't really are conducting the process or don't really need the suction capacity by then. So you don't have to permanently run the system at 100%, but you can regulate the operation of your vacuum system, of your pumps in a smart way to not consume more energy than required. And in the end, of course, if we talk about renewing parts of the system, of course, also the pumping principle and the choice of pumping principle is impacting the energy efficiency. And we have one example standing here on our desk. So we have two different pumps, which are both providing high vacuum, but with totally different principles. And on the left side, we see that we have an oil diffusion pump, which is something like the traditional way of generating a high vacuum, as it has been in the 50s, 60s, and many of us have also been using it later on. And here we permanently heat an amount of oil and evaporate it, and the oil is moving through the nozzles to the outside of the pump housing, which is cooled by a water cooling permanently and cooled down. And while the oil is moving through the volume, it's dragging the gas with it, which then condensates on the surface and gets eventually moved out of the exhaust. So this is a pump where you have to permanently heat the oil, independently of which pressure range you are covering right now or which suction capacity you need. You're permanently heating, in this case with 900 watt. And on the other side, you have to permanently provide the respective cooling power. And on the other hand, we see a different concept, also providing high vacuum in this same pumping speed range in this case, which is the turbo pump. And the turbo pump is using a rotor and giving the gas, which is pumped, a certain momentum, moving through the higher pressure range and moving into the eventually into the outlet. But in this case, if you go to lower pressures, the energy that you have to give onto the rotor over the drive technology gets way less. So where with the oil diffusion pump, you have a permanent energy intake, the turbo pump over time will need much less energy. And that is something that you also see in your cost over 8 years. So if you see this the display of the costs of the two different pumping principles, you see that we here see a difference of about 100,000 euro after 8 years in operation for energy cost.
Yeah, it makes sense. You're having a pump which you're heating and cooling at the same time. If you compare that with a pump that is running without any friction, even the magnetic levitated, without any bearing friction, just in a vacuum environment, the difference in energy consumption is huge. We do some calculations on projects here, and we see the return. It's depending on the country and the operating hours, of course, but the return on investment could be 2 or 3 years, even to have your investment paid back. So
exactly. So definitely something worth looking into. And this is only an example. So it's also the topic when you compare dry pumps and wet pumps, there is difference in the energy intake at the different pressure levels. So also here, it's a matter of process. So key findings for the energy savings, we definitely recommend that you review and understand what kind of technology you are using on your systems, and also in the same terms, be aware on possible alternatives. So what is happening in the vacuum market? Is there new products? Is there novel drive technologies that you could use, which give you, for example, similar performance, but which helps you to save a bit of money? And then you can actually save cost, also looking into cost of operation, also into maintenance cost, for example. You can save time and also a lot of maintenance efforts in some cases if you invest into more efficient technology. And as you just pointed out, Simon, it can be the case that you have a very, very close return on invest if you do so. So it's definitely worth looking into that, and it's definitely also worth looking and reviewing your process requirements and sequences, whether you can take a benefit of flexible operating modes like standby modes when you don't need the full suction capacity. Yeah, and also a very, very interesting topic that we want to talk about is possibilities that you gain by using smarter communication. We have one example here, which is a pressure gauge, a full range pressure gauge that you can apply to your system just to measure the vacuum level where you're operating. In the conventional case, you would have this pressure gauge, and you would connect it with a cable to your PLC or to an evaluation unit, which is somewhere in the rack. And in that evaluation unit or in the PLC, you calculate the actual pressure level. In this case, it's a bit different because we have the evaluation unit directly on the system, because this is a digitalized gauge where you have the analog digital converter right on the system. You also have the algorithms to calculate to a pressure value and eventually translate it into the language of a bus system, which can be an RS485, which can also be a field bus system like a Profinet or the EtherCAT system, and then can directly communicate with your PLC without any loss of data, without any analog wiring, because in this case you can, for example, if you operate 5 pressure gauges, you can just do a daisy chain and don't have to operate 5 cables in parallel. And if you don't want to make that effort, you can also use the display, for example, and have it directly in your hand. Yeah.
We also have another webinar only dedicated to the digital gauges on our website available. Also strongly suggested for those who want to update that part of the code.
Yeah. So simply using digital communication can give you some benefit, looking into the ease of setting up the system, of wiring it, and also of losing information during the transfer of the signal. But there is also more to it, and that also is not only the case for pumps, but for gauges, but also for pumps and other equipment, even valves, that you can use when you are working with the sensor data and the operational information on your pumps. So, for example, here we see some. We sometimes just say dump pumps because we have no digital equipment on the pumps. It's working with an asynchrone motor, and there is no intelligence or no frequency converters even on the pump here. But you can apply sensors to the pumps, for example, to monitor temperatures, to monitor vibrations, and to just keep in sight what is the situation on your pump. And when sending this data into a central IoT system, for example, you can constantly monitor the situation of your equipment and constantly have an insight into the condition of the equipment that you're operating. And that can help you even to gain some benefits and gain a more safe operation.
Yes, definitely. Yeah.
What we see here is an IoT system. So that's a central system run on a server where you upload only the data of your pumps, no information on the process that you're conducting, but for example, temperatures of your pumps and operating parameters of the pumps, like the power intake temperature, as I said, and you monitor it. So you have a permanently information on which status your equipment is running.
This is happening more and more. We see this in the field. We see this in the market. Yeah. So many companies, also we as a pump supplier, we have thousands of pumps in the field right now that we can monitor, that we can see. Yeah. Just a pump, not a process. And this is really happening. And this is over the last 2 years, I can say there's really a trend upwards. But the advantages are huge. You can predict or prevent a failure of the pump. But you can also give warning messages, and this as a pump supplier, but also for the machine builders in the audience here. If you have machines and you can give a real example, we can see when the exhaust filter could be blocked, for example, and we can give a simple call to the end user: "Hey, pump X in the on that installation has a higher pressure. Go check your exhaust filter." These are things that are happening more and more right now. So
exactly. And out of the Bush Group, we are providing this service in terms of our auto service product, which is containing also the access to an IoT platform where you can monitor and also evaluate the data of your pumps. And that actually includes also smart evaluation. So you can really predict when a pump will have or will run into the need of a maintenance. And it also helps us to plan the maintenance of the equipment. So in general, you could say you can really save money by avoiding downtime, because the most expensive thing is when the equipment goes into failure mode without announcement before. So if you can predict that and save downtime, that's definitely something where you can save cost. But also for us, we can plan the maintenance, because we see when your equipment will be requiring maintenance, so we can be faster and also reduce downtime because you have back your pump much earlier. And also the first time fix rate, which means that we instantly have the possibility to fix the equipment, that we have the right spare parts available, for example, also is rising when we use an IoT solution. So that's something which is also worth looking into, whether it makes sense to go into the digital world and actually use the data that your pumps and that your equipment is producing. Okay, so that's the 4 reasons that we wanted to discuss with you for renewing equipment. And I think now we can go through some typical cases.
I'll try to catch up when I look at the clock. It's going to be faster. A few typical. This is just one example that we picked out. This installation is like many other installations. You know, vacuum systems have quite often the same parts, the same components. There are pumps. Otherwise, it's not a vacuum chamber. There's a chamber. I said it myself. Can be small, can be big. There are gauges. There are valves. There are components. In many cases, it's always the same things coming back. Yeah. So what we will take a look at on this machine, for example, let's start from atmospheric pressure. Yeah, the backing pump or the 4 vacuum pump. Yeah, it could be an old one. We saw on the pole that there are several older pumps. Well, it could be a reason to replace it, and then you can think about dry. We saw in the poll with the people interested in dry technology. Yeah, it's not so complicated to use the same machine to do a replacement. Shouldn't take too long. Yeah, and the investment could be paid back after a quite short time. Yeah?
Maybe also review the process that you are conducting in the system. Maybe the system has been purchased 10 years ago and you were conducting a different process by then. And by now, the process requirements have changed. Maybe you can switch from a 2-stage to a 1-stage rotary vane pump and save some money. Or also looking into the energy consumption. If you're working, for example, with a screw pump, investigate different possibilities, investigate a multi-stage roots pump, whether it also serves the process and maybe consumes less energy. So there is many aspects to it, and it's always up to the process.
Changing the pumps on this installation would be easier than changing the heating system in your house.
For sure.
Second part, this roots pump. Roots blowers, in many cases, the working horses of the installation, quite old technology, proven technology, volumetric pumps, industrial beasts, so to say. We see a trend where this big piece of metal gets smaller. and gets running at higher frequency. We have way better production technologies to have the pump safer on these higher frequencies as well. Yeah, and that makes them also more intelligent. There is frequency controlling, but there is also way more feedback on this. So that could be definitely a reason also for energy saving. The bearing system is different, the sealing system different, so that will lead to energy savings if you look at older pumps. And now the interesting thing, these two, backing pump or the vacuum pump and roots pump are more and more into one unit. This is not new. The concept is existing, but we see definitely a trend in the market. We as a pump supplier as well. That means you have a box. We call it the plug and pump system with a touchscreen on board where you simply have to connect electricity, water cooling if it's needed, nitrogen for sealing gas if it's depending on the process. Just plug it on there, and you can even say to the pump, I want to go to this pressure, and it's fully controlled. Many sensors on the inside. This is a trend we see. Is it a must? No. You can also go for these, single pumps as unitary pieces. Definitely possible, but these plug and pump box systems are definitely a trend we see, especially for batch machines. It could be interesting to have one when there is a replacement or an exchange. It's quite easy to do without a very minimum or limited production stop. Last part on this, the turbo pump. I think Martin explained it quite well. If you still have an older diffusion pump, definitely look at the return of investment. If you have turbo pumps, if they can have a very long lifetime. We know that. We also know that people start now proactively replacing the electronics on board because they can be the first failing part now. So this is definitely something we suggest. Be aware that if your pump has a certain age, the electronics might be failing.
To wrap it up. So I think we highlighted some aspects of renewing equipment on vacuum systems today. In general, it's important to keep in mind what's the status of your system to secure high quality of your products, and of course, in the same correlations, understand how vacuum equipment, a choice of vacuum equipment, is influencing the quality that you can produce. And also for the cost, it's very important to secure a very good uptime rate of the equipment. And also for your workers around the system, which are working with it every day, be sure that it's safe and that it's all right to be operated.
Yeah.
And in the end, of course, we're doing this for a living, so we all want to make money with it. So if you can save costs by choosing the right vacuum equipment and planning a bit ahead in the future, it can be always very interesting.
Yeah.
So I think
a general message is also that we want to share. Don't your machine, even if it's an older machine, with some minor upgrades. I think with the story that we told, it are not the biggest investments. It's not a complete game changer. It are minor updates, and your machine can be ready for the next generation as well. So this is the message we wanted to give.
And with that, we want to say thanks a lot to everybody who stayed with us until this time. And before we go into the Q&A session, we want to highlight again the possibility that you can, of course, receive the slides that we showed you and the material. Just take part in our post-webinar survey after we have closed the webinar and let us know whether you want to receive the presentation. And I think there are quite some questions that we can discuss. Of course, if we do not answer your question right now, we can get in touch later on. And also, for example, if tonight in the evening you're sitting on the couch and then you have a burning question about how to renew your vacuum pump, you can also reach out to us later on, because here you have our contact data on the slide. So let's take a look at your questions. So here we have a question about replacing a diffusion pump. When I think about replacing a diffusion pump with a turbomolecular pump, the flange sizes differ. How to deal with this?
Yeah, that's indeed a common situation. So a diffusion pump in general has quite big pumping speed. Yeah, it's not easy to replace it one by turbo pump. Can be in this example on the table. But that doesn't mean that the story is closed for this upgrade. We know that diffusion pumps, for example, have the angle valves on top. Yeah? They're always mounted in this vertical position, of course, for the oil. Yeah? And in many cases, there's a lot of conductance on these angle valves. And if we replace the turbo pump on the horizontal position, it doesn't. You don't need the same pumping speed. Yeah, so it's depending on the values. But you can, for example, replace one diffusion pump with a way smaller pumping speed of turbo pump if you put it directly on the chamber.
Yeah,
if you have that possibility. And we also made some special adapters. Can be to mount 2 or 3 turbo pumps on one big flange on the side of your machine, where several turbo pumps can be sometimes in straight lines, sometimes in an angle shape, can be mounted. So this is definitely, there are solutions, technical solutions for this.
That's all things that we have been through. So there is also experience on that, of course. I think the next one is an interesting comment which I'd like to highlight. So here someone writes, it depends on how old the system is. They have systems that are more than 20 years old and other systems which are completely new. Also an interesting aspect concerning maintenance. In some cases, you want to have a common field of pumps where you can simply exchange also between the systems. Can also be a reason to think about upgrading the pumps on the older systems. But I mean, if the old pumps are still serviceable and operating, is also completely fine to use both in parallel. Very interesting. So someone is asking, are there really still applications where oil diffusion pumps are used? Yes, indeed. Yes. That's something that we see.
Yeah.
And I mean, that's something that I like to tell from my university time. I was working on an ion beam etching system with an oil diffusion pump this size, and it was always funny using it, because when you switched it on, it was like crack, 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 and then it started to operate, and it really pumped for the first 2 or 3 decades. It was like really fast, but there was a water-cooled baffle on top, and there was a nitrogen-cooled baffle on top, and of course, at university, as a student, you don't care so much about operating costs. So, but yes, there's still oil diffusion pumps used in metallurgy applications, for example.
Yeah, definitely. Yeah, we definitely see them in the field. Sometimes there are good reasons to keep them. Yeah, I'm not going to say it's bad pumps. It's really proven technology. Yeah, the keep it simple approach is definitely valid for these diffusion pumps. Yeah,
for sure.
But
it's a matter of process.
Yeah.
Again. Yeah. So, someone is writing, we tried several dry pumps and they are all dying over a short period of time in our processes. Are dry pumps less resilient in special circumstances? So in general, I would not say that dry pumps are less resilient, but of course, again, it's a matter of process. So if you have a dry pump, which is, it also depends on the choice of dry pump, which is sensitive against dust, or which is experiencing condensation at some point, then of course you can have a failure which you would not face in an oil sealed.
Yeah, we can really state that dry pumps can be really resistant pumps, but you have to understand your process. I think this is a key message. If you change a pump by another pumping principle, you have to review your process. You have to think, and that could be, there are inlet filters, but it could also be injection points of gas in the inside of the pump. Yeah, we have different points as gas ballast, generally used for water vapors or other vapors that could condensate in the pump. But there are also protection systems, also on dry pumps, and we have to think about that. But this is maybe not the application of the audience, but when we compare to semiconductor industry, that are way more dirty processes.
Yes.
Yeah, there's a lot of nasty stuff going to these pumps. Well, in semiconductor, it are all dry pumps. Yeah, so we can have really high resistant, process resistant pumps in the dry version as well.
For sure.
Yeah,
and it can be even the other way around. So you can also observe in some processes that you have a rotary vane pump which is oil sealed, which can die very soon. Whereas in the same process, a dry pump is working for decades. So it's really up to the process, but that's something that we can also discuss later on directly with you if you like. So let's take a look, maybe to the up here. I think there was some topics. So even from one to another turbo pump, there can be a different behavior, and there's differences between turbo pumps that you are using. Yes, that's right. There is magnetically levitated turbopumps. There's hybrid Baird turbopumps. There's also different characteristics. Some turbopumps are operating at comparably high pressures into the 10 to the minus 2 millibar range.
Yep.
For example, when helium is circulated in a cryogenic process.
Yeah.
And this is a bit also specialized turbopumps, which look a bit different than this one, with a small flange and a large body. But this really depends on the
every turbopump has a pumping speed on different gases. So we have special pumps that are better in pumping light gases, and other are better in heavy gases. So this is really a change in. I see another remark or question here. Can you achieve is it 5,000 or 50,000
liters
a second with a turbopump? So no, the highest is 4,000 liters a second, but of course we can put several pumps.
You could.
Even on the position of one diffusion pump, I explained it. We have made adapters where we can have several turbopumps on one.
But of course, it's a matter of feasibility.
Yeah.
Of course, you can multiplex turbopumps in parallel to go up to these pumping speeds. But yes, this, of course, if you talk about 50,000 liters per second, this could be a point where we still need to discuss and think about oil diffusion pumps, about other pumping principles. And that's completely all right. Because in the end, it's a matter of process. So it's a matter of what you want to achieve with the vacuum and how we can serve the process the best with choosing the right pumps. Okay, I think
these are all
that's we have some. Oh, we have some more to the top. Oh yeah, can any normal pump be upgraded to an Artex pump? An intelligent pump later, or a complete new pump requires to be installed? So concerning Artex, it's pretty strict. An Artex pump, when we produce, so for example, for the broad audience, short explanation, Artex is a special certification for explosion-proof equipment. If you are operating with explosion-proof atmospheres. And when we are selling an Artex pump, so a pump with an Artex certification, this pump is usually going through a much higher and more complex quality check process. So even the single parts are measured in the measuring room with much more effort. We are also doing some additional checks while commissioning the pump for the first time. So there is nothing that you can buy to upgrade a standard pump to an Artex.
No, I want to say the answer is no. I'm quite sure. But I see in the question also, can it be upgraded to Artex/intelligent pump? Intelligent, yes.
Intelligent, yes.
So this is definitely something we're working on, as Martin explained. If you have an old or an existing pump with just an electromotor as the only electrical connection you have, we have more and more sensors that are custom made for the existing pumps in the field to make them more intelligent. So yes, there the answer is yes, but it doesn't make them an Artex version.
Yeah, that's right. Okay, I think that's about it by now.
Yes.
As I said, if any questions come up in the time after the webinar, just let us know. And that said, I want to say thank you again for being with us today, for participating in our polls, for watching our talk. Now after the webinar, as I said, you have the possibility to get our slides for sure. And of course, we will be happy to get in touch with you personally to discuss about any vacuum needs and any questions later on. Thanks a lot and have a nice day.
Thank you very much. Bye.